Okay, more review. We're at section 1.15, solving linear equations. If we wanted to find the value of x from this equation, the goal would be to get x on one side, x equals, and then a number. So we're solving for x. In this case, I'm just going to do 2 examples, and that should be enough. First, we're going to expand the brackets. So 3 times x, 3x, 3 times -4, it's -12, equals expansion again. 5 times 2x is 10x, 5 times 3 is 15. Okay, then because we want x by itself, we only want it to be on one side, right? Let's take the 3x away on this side, and what we do to this side, we have to do to that side as well. So I like to write it like this because it's just faster. So negative 3x on both sides. What does that give us here? 3x minus 3x is nothing, -12. 10x minus 3x is 7x plus 15. All right. We want the x's on this side, so this loose number here, 15, we don't want that there. So we're going to subtract 15, and we have to do the same thing on the other side. -12 minus 15 is -27 equals 7x plus 15 minus 15, that's just nothing, right? So now I have -27 is 7x. To get x by itself, we divide this by 7. 7x divided by 7 would be x, right? So divide by 7. Do the same thing on this side, divide by 7. -27 divided by 7 would be 7x divided by 7 is x. I like to turn it around. Let's do that first. X is -27 over 7. This is an improper fraction. We can take whole ones out of there because there's 21 sevenths in there. So x is, it's going to be a negative number. 3 whole ones, 21 sevenths is 3. And then we have 6 sevenths left. So this -3 and 6 sevenths is the value of x in this equation. Okay, say we had this. Say there's a fraction in there. You could get nervous, but there's no need to. We want x by itself. There's a loose number here that we want to get rid of. Let's add 2 to get rid of that. We do the same thing to both sides, right? So we have here 3 over x minus 2 plus 2. That's just nothing, right? Equals 8 plus 2 is 10. X is the denominator. We don't like that. We don't want it to be on the bottom here. So how do we get rid of it there? We multiply by x. Do that on both sides. So 3 divided by x times x is 3, right? 10 times x is 10x. Does that make sense? 3 divided by x multiplied by x, x is just 3. 10 times x is 10x. Okay. X is on this side now. To get x by itself, we want to divide by 10. Oops, I didn't leave any room. Divide both sides by 10. 10x divided by 10 is x. 3 divided by 10. Oops, sorry. So x equals 3/10. I like having x first. We can't simplify this any further. We can't, it's not improper, so we just leave it like that. Okay, So there's many more examples in the book that you could try. Next section, constructing formula. Let's say a pear weighs 250 grams, an apple weighs 200 grams. We're buying 3 pears and 2 apples. How much is that going to weigh? Construct a formula that'll give you the answer. The question is, how much does this weigh? 3 pears and 2 apples. Wait. Am I saying this correctly? No, I'm not. Yes, I am. Well, yeah, okay, so this may be a bit too simple. It is too simple. This would be 3 times the weight of 1 pear, right? 250 grams, plus 2 times the weight of 1 apple. And that would be 3 times 250 grams, it would be 750 grams. This would be 2 times 200 is 400 grams. So 750 plus 400 is 1150 grams. Now say we didn't know how many apples and pears we were getting. Say we said we just always want to get a certain number of pears. We'll call it X. X is the number of pears. And we always want to get 2 more apples. So the number of apples is always going to be, did I say 2 more? I said 2 more. X plus 2. So when we have 2 pears, we get 2 plus 2, 4 apples. But when we buy 8 pears, we buy 8 plus 2 is 10 apples, right? Now, we can find a formula that'll tell us how much this is going to weigh, no matter how many pears we decide to get. And the number of pears we get will determine how many apples we get, right? How much is this going to weigh? So the final weight, let's call that W, is going to be 250 grams times X, right? Plus the weight of the apples, which is 200 grams, 200 times the number of apples, which is always X plus 2. So no matter how many pears we get, we plug that in for X and it'll tell us how much it's going to weigh. But we're not done because we can simplify this, right? We need to expand here and then collect like terms. Expand here. Okay, so W is going to be 250x plus 200x plus 200 times 2 is 400. We have 250x and 200x and some loose 400 grams. 250 plus 200 is 450x plus 400. So this is our final equation for the weight of the fruit that we're getting. So when we figure out how many pears we're going to buy, we plug that number in for X and it'll tell us how much our pears and apples are going to weigh together. Constructing formula. Fun. Sorry for messing up there for a while. Made it too simple. Okay. Now, so we just came up with our own formula to find the weight of our fruit. sometimes they'll give you a formula and they'll ask you to find, no, I'm just going to tell you the story. Say this is the formula to find the cost of renting a car, where N is the number of days. So the cost of renting a car is $120 plus 45 times N, N being the number of days. So depending on how many days you're renting the car for, your cost will go up. So this is all given. Say they ask us, you want to rent a car for 5 days. How much is that going to cost? Using this formula. Well, all you need to do is say, okay, 5 days, N is the number of days, so for N we plug in this 5. So the total cost is going to be 120 plus 45 times N, but N in this case is 5 because we're renting it for 5 days. So the cost is going to be 120 plus 45 times 5 is 225, right? So the cost is going to be $345. And this should say C is the cost of renting a car in dollars. Yes? So substitution into formula, that's just plugging in the correct number into the variable. All right.